Thank you, Ryan. Thank you, Toyota. Thank you, Karen, Don, Brent, for the very kind words. I'm truly appreciative and grateful. You know, going on a career trajectory like I have takes a village to do that. I want to begin the presentation talking about, well, first I should turn this guy on here. Talking about the ways in which I'm grateful for the honor to stand up here. I want to thank my family first. You know, this is a very involved career trajectory, as many of you in the career path know. And through every curve, they've been with me, and it's really been a pleasure. You know, but but over time, I've had many mentors in my career. You know, that have helped lift me up and teach me how to be. You know, from my advisor Greg and Alan, PhD and postdoc advisor, who spent just hours and hours training me to be a scholar, what that meant, to appreciate the fundamentals, you know, to go deep, to be careful about your writing, to recognize that you're marketing yourself at all times, even if you mean well, it's still marketing. You know, to Roger Eastman, who drove me from Baltimore, where I went to college, tiny little Jesuit college, to College Park multiple Fridays to attend the computer vision seminar, like the classical computer vision seminar that Azriel Rosenfeld founded every Friday. I think he took me there 2 or 3 times. Fantastic. Or Alison Okamura. My first paper is with Alison in a field totally unrelated to computer vision in haptics, but it was a class project, and she was so supportive of like the quality of the work that myself and a classmate, Jatin Chugani, did, that she sent us to Edinburgh. You know, at that moment I was hooked on academia, right? I can go to anywhere I want based on the work. That's fantastic, right? Or Jeff Siskin, who drove up here from West Lafayette just last night to attend, who's just a paragon of like creativity and understand the details and the fundamentals. You know, and Jeff Fessler is on the slide here, but it's here to represent the many Michigan faculty that are just so supportive. And also, I probably wouldn't be here without Jeff, because wherever Jeff is, I saw him before, because Jeff was the chair of the faculty recruiting committee in 2014 when I applied, right? So there you go. Awesome. And I also want to thank my parents, who instilled in me a deep bias to action and a deep groundedness of just what it is to be human. And maybe even more importantly, right, to splurge in 1984 or 85 and buy me a Commodore 64. Right? They were like, wait, maybe this microcomputer thing it's a thing. Maybe we should do it, right? So working class, not, you know, this was a decision to do that, and I'm just super grateful. You know, and as Don said, I'm in computer vision. Many of you know me as someone in computer vision, so probably you're expecting me to talk about pinhole cameras that you can make out of boxes and tissue paper, or perhaps even as a middle schooler through the Explore Engineering Camp that we ran, a coffee cup and a lens you just held on the back of it with your finger. Or maybe you're expecting me to tell you about how difficult it is to do computer vision, right? Like for the computer, not the human, right? Humans do a lot of crazy things, but vision is hard for a computer. It has no prior experience. Human babies are born and they immediately begin seeing. We have hundreds of thousands of hours of data. Initially, it's actually mostly in the same space. So you get to know your mom, your dad, your kitchen, your crib, and so on. Computers have nothing. They start carte blanche, complete carte blanche. So I'm going to give you a quiz now. I told Cam earlier I was going to give a quiz, right? It wouldn't be this talk without a quiz. This is an image rendered in a way that you're not used to. So it's a photo, and it's rendered, so you see the vertical axis, height, the horizontal axis, width, and the intensity of the pixel is rendered as the height off the plane. So it's a 3D image. I should have done it as a GIF, but actually Gemini helped me write the code for this just last night. So there you go. What is this an image of? This is my quiz. Anyone know? Dude, you're awesome. Nate clearly studied computer vision. Nate is one of my past students, by the way. So it's this building, right? Just I'll give you a couple features. Just look at this wall right here. You can't really see that. This is a little gray wall. look at the light post and the curve, and then you'll be able to see it, right? You can see the gray wall right in the middle there. You can see the wall, and so on, right? Computer vision is really hard. You know, I'm so much of a computer vision guy, as Don said, right? Like, I started a company whose goal is to basically become the vanguard open source tool for building computer vision systems. And I'm so grateful for our millions of downloads, you know, tons of community members, our team of more than 60 individuals that come from across the nation, actually across North America, to go and build this with me. And indeed, I sourced them locally. This was that course in 2014 where Brent, look how happy Brent was, right? He was like, I am so in love with being here. And this is a grand picture of Brian Moore, who's my co-founder, who's his advisor, Raj, is sitting back there as well. You know, and it's just been a great pleasure to have that trajectory in computer vision. But if I kept giving you a talk about computer vision, I wouldn't be doing my actual lifetime to justice. So really, you know, computer vision pays the bills. I know how to do it, I was trained in it, and it's interesting. But it's only one facet in one puzzle piece in a broader puzzle that is what I want to build and bring to the world in my career. And I think that puzzle might have begun with this.
Will you be the one to witness the birth of the incredible Nintendo Entertainment System? The one to play with Rob, the extraordinary video robot, batteries not included. He helps you tackle even the toughest challenge.
So I watched this commercial around the time I got the Commodore, maybe a year or two later. I was probably 6 or 7 years old. And it just blew me away. It planted the seeds that would grow and blossom into a career trajectory. I mean, the notion that, you know, this little 6-year-old boy that loved video games, had a lot of friends, like, would be able to have another friend that was a robot that would help play games with him, like a teammate, like, isn't that amazing? I remember this moment. I don't know exactly when it was. I grew up in Queens, in New York City. We're going to go across town to go visit some family friends. I believe the mother's name was Carol, for some reason that sticks with me. And they had a Nintendo. And no one on my block had Nintendo yet, so I didn't know what to expect. I thought we were going to go see Rob and actually play with Rob. And I was so excited. Like this was genuine childhood glee. We got there, and instead of that robot, there was this gray plastic box, you know, the 8-bit Nintendo console. I was so let down. I was so brokenhearted because, I mean, I wanted the robot, right? In fact, though, Nintendo kind of, well, they pulled Rob off the shelves, actually, not long after they put it on the shelves, because it was just way ahead of its time, right? Like, you couldn't really do much with the robot. But, like I said, even if it just impacted me, I'm sure it impacted other people, like, it did plant seeds for what I wanted to build in my life, really, like to build these partners, these teammates that could help humans work better together and make a bigger impact. And so I went through the last 20 years of my publications just to see if this is not just a made-up story. Like, oftentimes in academia, you'll do a lot of things and you'll try to patch a story around it, hopefully in the best. And I found this sequence of papers that actually build out that vision. And in some sense, it's just beginning. So we had a paper in 2003 that we called the 4D touchpad, in which we used a projection-based interface in a mirror system from underneath the table. This is just a piece of wood and a plexiglass and a piece of paper on top of the table that we borrowed from some other project. And we created an interface and used an overhead camera system to understand the multi-touch interaction on that piece of plastic. Multi-touch, plastic interface, 2003. Furthermore, we then built it out into the X window system. And so we were able to wrap the API, the application program interface of X Windows, so you could actually use your multi-touch in Linux in 2003. This paper here, we were building out gesture recognition capabilities. We had a sequence of papers around that time as well for what you can do on top of the device. Show me the iPad that can do gesture recognition on top of the iPad, for example. This is a funny, the life of academics is interesting. This worked really well, like 98 to 99% accurate. 2004, real time from an analog camera that had to go through a digitizer in the machine, and it used the neural network to do the inference. We were handily rejected from CVPR. for submitting that paper at that time. Anyway, so, you know, and I was thinking, okay, if I want to build these systems that understand and work with humans, well, I need to understand humans more as well. So I spent 2 years in neuroscience and radiology and statistics with Alan Ewell at UCLA. And this is just one example of the work we did that tried to seek out anatomical modeling of the human brain through machine learning at the time, probabilistic graphical models. We had numerous follow-on papers, some with actually Jeff as well, that dug even deeper for what is the semantics of what's happening inside of these brain structures. And of course, one of the biggest frustrations is language. And the fact that from the early 80s, even the late 70s when the Xerox Star was becoming more popular, through my Commodore when I had the GEOS windowing system, there was this paradigm of windows, icons, menus, and pointers. We all know it today, it's natural because we all still use it. It's kind of crazy that in 2026, we're generally still interacting with our computer system in the way we did in 1975 before I was born. And so, to build a system that was actually going to be a teammate, one needs to use language, incorporate language into that system. So this is the masthead figure from my career award in 2008, which essentially defines the image captioning problem. Input an image, do low-level vision, find the things in the image, build a relational graph, a scene graph as that's now popularly called over it, and then reason about what that might mean in the context of a problem, and output a description. Nowadays, you can do this on your phone through a cloud connection with various tools like GPT, Gemini, whatever. It took us, so 2008, took us about 5 years to actually realize that capability. You know, hard work, not a lot of publications on this until the 5th year, where we could, in video, I don't know if this was real time or not. I don't think it was real time. In video, do detection, do tracking, map the objects into that relational scene graph, connect them to a structured ontology, and actually generate the sentences that you see at the bottom, even when there's distractors like the car driving by. We even, at that time, set up a website, videototext.net, where you can upload your own videos and get translation for you. Right, so language, human, neuroscience, and human brain. What about the physical environment? So I had a sequence of works that tried to bring more capabilities to robotic platforms that would be required if we were really going to build these physical cognitive systems, physically enabled cognitive systems. For example, this is a collaboration with the Army Research Labs, where they use the PackBot as at the time, as their de facto, their standard ground-based platform. The PackBot was a fabulous platform that could even climb stairs, but it couldn't tell what stairs it could climb, so it would just kind of be lost. The semantics of the understanding was kind of lost. So we enriched it with the capability. As far as I know, this was actually deployed to all the Army Research Labs, PackBots. Okay, so we have physical environment, we have new interfaces, we have language, we have the human, but what else about the human, right? So if you think about it, that windows, icons, menus, pointers metaphor, or even like many of you had to program a VCR in your day, right? Like you, as the human, have to adapt yourself to the system. We've had to do that with technology forever, basically, right? So, so we began a trajectory of work that still goes on today with a collaboration with Seoul National University through the AFOSR that basically allows human feedback in the loop to modulate the objective function over which a computer vision system or machine learning system is operating. Here's a beautiful dog. I don't know what dog this is. This is from the web. Here's another beautiful dog, a Bergamasco Shepherd. Now, in classical structured, labeled supervised machine learning, the problem is this a dog or a cat or something else, right? So what's the question we will actually want to ask? In practice, though, is that the only question we can ask? Absolutely not, right? I can ask, are these dogs? I can ask, are these the same dog breeds? No, they're not the same dog breed. I could ask, are these the same dog breed? Yes. Are these the same actual dogs? No. The one on the left is my dog in my backyard in Chelsea, right? Like, so like the details over which, like what cost function you're optimizing truly matters on the fly, and it has to be adapted on the fly based on the situation. We humans do that. You should all like just pat yourselves. We are amazing. The human is an amazing being. Here is so this just an example work is this notion of active clustering. So we would basically ask a human in the loop, for grouping constraints over samples. And depending on what their goal was, dogs versus cats, dog breeds, brown dogs, black dogs, white dogs, they would answer differently, and the actual latent space would morph and change to realize the output. Okay, so a lot of those were the pieces, right? So that was about halfway through my faculty career so far. And at some point, you have to sit back and think like, wait, is there a principle behind what I've been thinking through, right? And like classically, like that's why I'm a computer vision person. Brent is a controls person, right? Like we silo ourselves into different areas. And I think that is absolutely the wrong way to go about research in the 2020s, in the 2030s. And so I characterize this as an entanglement for cognitive systems. In order to truly build the type of partners that I envision, one needs to do perception. One needs to involve human semantics. One needs to think about the context, the physical environment, the task to do that. And I believe these systems are, these silos are actually entangled in a way that you actually must solve them together. And in fact, this is a 2013 slide that I'm still working on in some sense. These are my older two kids before the youngest one was born. And like, this is a problem we don't actually have a solution to yet, but this is where I'm working. I had the bravery to put this in my job talk slide here, actually. And I still think we're barely scratching the surface of building a physically enabled robotic platform that could actually be a team member with a human. Speaking of team members, all of this work is obviously not just mine. I've had the luxury of having an army, a small army of amazing students, postdocs, master students, programmers over the years, so much that I certainly couldn't put them all on the slide here. But then even think about the next ring outside, other committees that I've been on, undergrads that come through in a course project or things like that. People really do bring this together, and also connections outside of the university. So I'm super grateful to Toyota Research, because I think Toyota really helped me establish a platform on which to say, okay, look, I know I'm a computer vision guy historically, but my real career dream, my life dream is to build these interactive cognitive systems. So I've had projects with TMNA just down the street in which we have a funded or a US patent that was approved for predicting whether or not someone was going to change lanes ahead of you in your, when you're driving on the highway or when an AV is driving on the highway. I spent summer 2015 at TRI up on Green Road when, like the second summer it opened, I think it was, or maybe that was summer 2016, but working on multimodal autoencoders for understanding situational awareness for AVs. And then we had numerous projects that really began to pull these pillars together, and with some of these with Brent, some with others, and so on, around building these systems that would incorporate physical environment, incorporate language, incorporate humans. So this is robot slang. This is SLAM with language acquisition. This is a collaboration with Jeff, actually, back here. So we set up an amazing race-like testbed in which there was a tabletop robotic environment. The goal was to go from your starting point and find your 3 goals in the maze. The maze was reconfigurable. There were 2 actors, 2 players. First was the commander. The commander had a static view, like a map, a blueprint, a paper map, basically, of the scene. The commander knew where the goals were. The driver was the second player. The driver could only see out of the front camera of the robot and control it, but they had a text channel between them. And we set this up so they would curate a new language that would help them solve the race the fastest. We learned so much about the different phases of the task, right? First was localization, then was path planning and communication. Sometimes they got lost. And we ultimately, this was published, I think, at a Coral 21 paper. Ultimately, this still remains a useful data set today for understanding pairs of interactions. And we went even further toward the physically grounded cognitive system problem in a program from DARPA called Perceptually Enabled Task Guidance. So here we created an augmented reality-based AI agent through these head-mounted displays that would basically observe what a human was doing in a physical task, such as cooking. Maybe like this is actually a recipe for cooking a microwave mug cake. Simple recipe that works well. It was part of the program. And the idea is that this agent would observe what was happening. The agent was called Millie, observe what was happening, track the state of the event of what was happening. If you're about to use a wrong ingredient, it would tell you in your ear, because the head-mounted display has audio as well. If you missed a step, if you missed something, and so on. Right? So here you can see just an example of this running. This person doing the mixing is one of my current students back there, Yayuan. So it's walking through the steps, and I have other examples, but no time to show them, in which, indeed, we can detect incorrect steps and so on. And this project really morphed into the one that Karen mentioned, which is the biggest active project I have in my lab right now, which is an extension of that notion of creating an ambient intelligence in a real setting to guide a human to do the task appropriately. This is called Vigil. And the whole goal here is to recognize that in rural America, there's a shortage of physicians. Frankly, all over there's a shortage of physicians, even in urban settings, suburban settings, especially globally. There is, however, no shortage of health problems. Population's increasing. We just don't have enough ways of dealing with that. And so this whole program we're a part of at ARPA-H is creating this AI, physically grounded AI guidance that can observe what's happening on the fly and guide a generalist, so someone who's not a specialist, who doesn't focus on one area of medicine, but can do any one of 500 different procedures on any given day, guided by this AI system to go and deliver that effectively in rural America. This system's called Vigil. It creates the shared perceptual space through the use of projection interfaces again, just like the beginning, as you might recall. It projects the interface, the relevant information, onto the tabletop environment, onto the patient to not only guide the generalist physician, but also to help build the trust between the patient and the physician, right? Physician can't be wearing head-mounted displays if the patient is there as well, right? They need to understand that relationship. And it also guides them interactively to do, for example, fine-grained cardiac ultrasound. If you have a question about the procedure, you can ask it. Hey, Vigil, what am I doing wrong? How do I get a better view? And so on. We're about 14 months into the program now. If you ever want to do an ultrasound for the first time, either get one done on you or do one. It's upstairs, 3rd floor. We do ultrasounds in FRB. Yes, we do. We actually are going to be adding obstetrics-based situations, so I don't know if anyone is pregnant, but we'll hopefully be able to do that as well. Right, so I think this is really the heyday of collaboration. Or another way to put it might be that I think we're at an inflection point in our general ability to build, to study, and deploy cognitive systems that work with us, that team with us. And I think at the same time that we have a responsibility to remain grounded and keep humanity at the core. I mean, just look at how far we've come. So thank you very much. I appreciate that.